Hello, you're welcome back. All right, so remember we have actually dealt with the different phase in change of state of of a liquid. Okay, so and you know very well that this particular phase, from let's say this is point 1, this is 2, this is 3, this is 4, and of course this is 5. So point 3 is the mixture of saturated liquid, plus vapor. So that is what we have. This is exactly what this state is all about. Okay, so now what we normally read, the table, what we read from our table is basically, the table actually that we read so far is for this particular state. Saturated water, all right, actually takes care of this state, which is the saturated liquid vapor state. Okay, so when you get to the saturated water table, you can actually read the temperature, the saturated temperature given a particular pressure. And you cannot read the saturated pressure given a particular temperature. All right, so just for this particular phase, between phase 2 and phase 4, but we have not actually looked at how to do calculation for this for the phase of superheated vapor, and of course this other phase of compressed liquid. Okay, so that's what you're going to be looking at in this video. Let's start with the superheated vapor. How do you know that the liquid is at a superheated vapor state? All right, so how do we find out? Now, as you can see, if the temperature, this temperature here is Tsat. Now, if you can see the temperature of a superheated vapor is greater than Tsat. So if the temperature we measure is greater than Tsat, then we now know. So these are the properties. Okay, so for superheated vapor, the temperature measured is always greater than the saturated temperature. The same thing happens with volume. Remember, volume is, as volume increases, this is VF, this is VG. Okay, so now of course after VG, all right, the volume still increases before we now enter into the superheated vapor. So that simply means that the volume actually keep on increasing. All right, so we can also conclude that the volume of the saturated vapor, the volume measured, the volume of the vapor measured is greater than the volume of the saturated vapor. So once the volume measured is greater than the volume of saturated vapor, then we can also conclude that this is actually superheated. It's not just volume, even internal energy, it also goes a long way. The internal energy is greater than the internal energy of the vapor. The enthalpy is also greater than the enthalpy of the vapor. So the only thing, remember, from the relationship, this is very simple relationship for pressure. You know that pressure is always inversely proportional to volume. So in the case of pressure will be the opposite. So for pressure, the pressure of superheated vapor is always less than the saturated pressure. P is less than P sat. So by the time you are able to okay, compare and actually consider all these conditions, you will know if that particular, you know, the region that substance is, or the phase, okay, the phase that you are actually working with. All right, I think there is a question that we have to solve. Okay, let's look at example. Okay, so here I have an example. Okay, so the question goes this way: determine internal energy of water at 20 psia. So this is an English unit. So 20 psia, we don't know exactly the state, and of course the temperature is 400 degree Fahrenheit. So what we are going to do is this: to know the state, we are going to first of all go into the saturated water, okay, and check this pressure. So we are going to check the temperature of this pressure. All right, so let's do that first. All right, so here we go straight. Okay, now I'm going to saturated water, then I'm going to pressure. Okay, I'll go to pressure table. So I am looking at the pressure of 20 psia. Okay, so I'm using English unit. Okay, I'm using English units. Hopefully I have this. The English unit is yeah, this is English unit. Okay, so saturated water, let's go to, okay, the pressure. All right, okay, here, so here we have the pressure. So the pressure we are looking at is 20. Okay, so 20, okay, 20 psia, the pressure is 227.92. Okay, so the pressure is equal to 227.92. That's exactly what we have. Okay, 227.92. Okay, so, and that is in degree Fahrenheit. Degree Fahrenheit. So comparing this pressure to this, as you can see, the pressure that this pressure, okay, this saturated pressure, all right, is actually less than the pressure that is given. It says of 400. Okay, so this is saturated pressure, as a matter of fact, 400 degree Fahrenheit. And you know that if the pressure is please pardon me, the temperature, this is the temperature, this, we're looking at the saturated temperature at a pressure of 20 psia. Okay, so the temperature that we rate is 227.92. 227.92. Okay, so now if this is the temperature, now we are comparing it to what we have. This is the saturated temperature. Now discover that the temperature that is given is greater than the saturated temperature Tsat. So now we can now conclude that this is a superheated. This is a superheated vapor. So because it's a superheated vapor, so we are reading our value of internal energy from the superheated table. So we'll go straight to the superheated table of the liquid water, okay, of water. So here we go. So this is superheated water. So what we are reading it for the saturated water, okay, superheated water. So we are reading the temperature. The temperature we are reading is 400 degrees Fahrenheit. So this is 400 degrees Fahrenheit, and the pressure is 511.92. Okay. So the temperature of superheated, so let me call it Tx. Sorry, the pressure of superheated, okay, at the temperature of 400 degrees Fahrenheit. Okay, so what we have is 511.92, and of course the unit is okay, what's the no, this is the specific volume. Okay, this is specific volume. The pressure, we are looking for the internal energy. Okay, so this the internal energy. Okay, so that is the internal energy. Actually, we are not going to, the pressure is not what we are looking for. Okay, so the internal energy, so there was internal energy, that is U. So at 400, that is 1147.1. okay, so this is 1147.1, and that the SI unit is BTU per lbm. BTU per lbm. All right, so let's talk about the compressed liquid. Let's talk about the compressed liquid. So I will redraw the graph. So here we have it that this is the region of the compressed liquid. Okay, so this is the saturated liquid, and of course this is saturated vapor. So here is the compressed. So how do we really know that this is compressed liquid? As you can see, the temperature measured at this point is less than the saturated temperature. So T is less than T sat. Even the V is less than VF. V is less than VF. In terms of U, also U is less than UF. H is less than HF. Okay, so now, but pressure, remember, pressure will be opposite. Pressure is always greater than, okay, P is greater than P sat. So that is exactly how you will find out. All right, so let's look at some example. So example, okay, so we are to determine internal energy of water at, determine the internal energy okay of water at 20. Okay, is that, no, that is not, we'll solve this. This one was superheated, okay. So here we are to determine internal energy, okay, of water at the temperature of 80 degrees Celsius and 5 megapascal. All right. So now, solution. So since we have been given both temperature and of course pressure, we are not told if this is saturated liquid. Okay, so we're going to read this at saturated liquid. So we're going to read the T-sat is 80 degrees. Okay, so we are going to check exactly what the pressure is. Let's go to our saturated or liquid water, the English unit. So saturated liquid water at temperature of 80. Okay, at the temperature of 80, let's see what the pressure is. This is okay, this, we are looking at temperature table. Okay, so temperature of 80, this temperature of 80, the pressure is of 47. Okay, so at the temperature, saturated temperature of 80 degrees Celsius, the pressure Psat, okay, is of 47.416 kilopascal. Meanwhile, the actual pressure is 5 megapascal. 5 megapascal is greater than 5 kilopascal. So that simply means that P is greater than Psat. And once you see this particular value, you know that this is actually a compressed liquid. So the internal energy, now we are going to read it from the compressed liquid table. All right, so let's look at the let's check for compressed liquid table. So saturated water. Okay, this is compressed. Okay, for a temperature of, okay, temperature of 80. The internal energy, let's see what we have as internal energy. So the internal energy we have is 333.82. Okay, so the internal energy is equal to 333.83 kilojoule per kg. Okay, so please take note of that. All right, so we are going to look at more questions in the next video. Okay, so see you in the next video. Thank you very much.